Hello students, let us continue with the 3-address code. 3-address code is another intermediate representation. We have studied syntax tree and redag in the previous video. Now 3-address code. As the name indicates, 3 means there are 3 operands like this. Like see, observe here, T1, B and C. 3 operands and at most one operator at the right hand side of the instruction. Okay, so at most one operand on RHS and at 3 there are 3 address values or 3 operands. That is called as 3-address code. So how to write 3-address code for the expression? Let me explain with the help of the same example. A plus A star B minus C plus B minus C star D. Tag is written constructed like this, as we have discussed in the previous video. Now 3-address code. So what is first operation which would have taken place, that is B minus C, parenthesized expression. So answer or the result of B minus C will be stored in a temporary variable T1. Next to what do we want? We want A star B minus C. So consider another temporary variable T2. That is the result of A into T1. What is T1? T1 is B minus C. So A star B minus C is over. Next what we require? A plus A star B minus C. So use another temporary variable T3. A plus previous result T2. So this part is over. Next B minus C star D we require, right? No, so B minus C is already over, that is T1. So T4 can be written as T1 into D. Then finally T5 is given by T3 and T4. So on RHS we have at most one operator like minus, star, plus, star and plus. And at most 3 operands with the help of temporary variable. This is called as 3-address code. But sometimes we also need some of other variants for 3-address code. It is not sufficient to use this condition for the 3-address code. If it is a binary operator, it is fine. For minus, one operand is B, another operand is C. For star, one operand is A, another operand T1. Binary operator, it is fine. If you consider unary operator, unary minus, how will you consider 2 operands like this? Is it possible? No, right? Unary minus means A is equal to minus of B. So minus is the unary minus operator. Just one operand we need, that is B. So 3-address code may also take some other forms. What are those? We will discuss one by one. Forms of 3-address instruction. Some other forms of instructions are also called as 3-address code. Very important. Explain different forms of 3-address instruction with the example. So 3-address form comes with addresses and instruction. What can be considered as address? A name. Name means variable name or memory location name like A, B, I, etc. It can be a constant like 0, 1, 2, 3, any number, or temporary value like T1, T2, T3, etc. Okay, address can be any these 3. What about instruction? We can have different forms of instruction. First one, assignment. Assignment instruction may take this form. Means x is equal to y of z. For example, x is equal to y plus z. Op can be addition, multiplication, subtraction, etc. Or one more form, x is equal to op y. Another assignment, x is equal to op, I will take minus, unary minus of y. X is equal to minus of y. So this is also a form of 3-address instruction. Copy instruction, x is equal to y. That is also 3-address form. Unconditional jump like go to L, or conditional jump like if x go to L, if condition is true go to L, and if condition is false go to L or some other label. Another way, If x relational operator y, go to L. That is, if x is greater than relational operator, what are the different types of relational operator? Less than, greater than, less than or equal to, greater than or equal to, not equal to, equal to, etc. So, if x is greater than y, then go to a label. Okay, like that. So, these are also 3 address form instructions. Next, procedure calls. Function calls using param x means parameter x. What are the possible parameters used in the program? Then how to call this function call by using 3 address form. Call of p comma n. P is the procedure name, n is the number of parameters. So this form is required if you are using no return value, and we are using this form, last form, y is equal to call of p comma n means the return value of this function will be stored in y. This is with return value, and previous case is without return value. For both the methods, definition of parameters is like by using param x. Then another form is indexed copy, that is array. How to copy array values? X is equal to y of y and x of y is equal to y. So these type of instruction are also in the 3 address form. Finally, address and pointer. X is equal to ampersand y address, and x is equal to star y, that is value, or star x is equal to y. So pointers can also be used in the 3 address form. So remember, this is very important. What are the different forms of this one? Forms of 3 address instruction. Explain with example. Now, another important topic, data structures or representation for 3 address code. Student, please remember there is one lab program for this topic. Okay, representation, data structures or the representation. Let me explain the theory part first. Then you can execute that lab program with the help of CLM. These are the 3 different types of representation: quadruple, triple and indirect triple. Quadruple, as the heading indicates, which has 4 fields like op, arg1, arg2 and the result. Okay, 4 fields we have: op, that is operator, argument 1, argument 2 and result. Then triples, as the name indicates, we have 3 values, 3 fields. Temporaries are not used and instead references to the instructions are made. It is something like our value number method. Okay, T1, like T1, T2, T3. Temporary variables are not used. Instead, their memory references or indexes will be used. I will give an example for you. Then last one is indirect triple. In addition to the triple, it is triple only. We use a list of pointers to the triple. Let me explain one by one. Quadruple, triples, indirect triple with the help of example. Consider this example, very important. You may get problems under this topic. A is equal to B star minus C plus B star minus C. Unary minus we are using. Write the following. This is the question. We need to write 3 address code, quadruple, triple, indirect triple. Along with these 4, syntax tree and DAG also we need to write. Now, one by one, 3 address code. Let us use the different forms of instructions which we already discussed now. So first what to do? Minus C. B star minus C is one part. Another part is B star minus C. Then they are getting added and finally they are stored in A, variable A. So first get T1. T1 is nothing but minus of C. You can write minus like this, but to differentiate between unary minus and binary minus, we will use minus for unary minus. Okay, understood now? Why we are writing minus? To indicate it is unary minus. So T1 is equal to minus of C. Then what is T2? T2 is nothing but B star minus C. Correct, no? So T2 is B star T1. I think you understood. T2 is nothing but B star minus C. That minus C is already stored in T1. So I wrote T2 is equal to B into T1. Then T3, again we need minus of C. You can write once again T3 is equal to minus C. Okay, as well as T4 is for this part, another part, one part, first part and second part. T4 is B into T3. Then T5 is equal to addition T2 plus T4, and finally assignment. You may get one doubt over here, isn't it? Why we have to write minus of C and I mean here ones as well as here one. Why can't we use T1? Your doubt is correct if you get the doubt, because this is intermediate code. That is called as optimization. Optimization phase is already existing in any compiler. So if the programmer writes like this any number of instruction, that optimization will be taken care in the next phase of the compiler. So if you write twice or thrice like this, it is not wrong. Okay, we are not writing any optimized code, we are just writing an intermediate representation. So if the programmer writes like this T1, I mean for this minus C, one T1, first temporary variable it is T1. Once again for this minus C, another temporary variable T3, like this. So it is also fine. Suppose if you don't want to use like this, you can use just T1 over here. How does your code look? T1 is equal to minus C, this will be there. Then T2 will be there. Then directly you can write this step now. T5 is equal to T2 plus T2 you can write, right? T2 is B into T1. So T5 is nothing but T2 plus T2, and finally assignment. That is also fine. So don't be get confused why twice minus C we are writing. Just once also you can write. If you write like this, optimization phase will take care of reducing the number of instruction, as we discussed in module 3. Now, quadruple representation. Quadruple means there are 4 fields like this. What are the 4 fields? Op, argument 1, argument 2 and result. Op means operator. Consider this is our reference now. Minus of C. So operator is minus. So minus I wrote. What is argument 1? Argument 1 is C. Is there any another argument? No. So just blank. So this is blank. What is the result? Where the result is stored? It is in T1. Okay, fine. That's over. T1 is equal to minus of C is over. Result is T1. Result is T1. Argument 2 is null. We have only one argument. Argument 1 is C. Then operator is minus. Then what about the second line? T2 is equal to B into T1. Operator is star. First operand, argument 1 is B. Argument 2 is T1. And the result is stored in T2. So the line star B T1 T2. Then third line, same method of first one. I am not going to explain again. Fourth line T4, same method of the second line. That is first argument is B. So B. Second argument is T3. So T3 result is stored in T4. This line T5 is equal to T2 plus T4. Operator is plus. So I wrote plus. Then first operand is T2, second operand is T4. So T2 and T4 result is stored in T5. Then last one, assignment. A is equal to T5. Result is A, isn't it? Result is A. Operator is equal to just an assignment. So is equal to is itself is an operator. Okay, clear now? Don't get confused. Previous one you have equal, but one more operator lies in the RHS also. So operator is RHS. Okay, following, right? So here is assignment itself is the operator. So operator is assignment. Argument 1 is T5. There is no second argument. This is how to write quadruple representation. Now second one is triple representation. We don't have this result field. Result field is not there. Other 3 are same, op, argument 1 and argument 2. Instead of result you have index like this 0, 1, 2, 3, 4, 5. Okay. First one consider minus of C. Operator is minus. Okay, argument 1 is C. There is no second argument. Blank. It is stored in index 0. Okay. Second line B into T1. Operator is star. Multiplication. First argument is B. What is second argument? That is minus of C. But minus of C is already stored in index 0. So 0 has to be written. Following, right? Instead of result, its index is used. These are the indexes 0, 1, 2, 3, etc. The indexes to store the result. Minus of C is stored in index 0. So, in the place of minus C, I wrote 0. That is the index. Similarly, next another minus C. Same thing. Index 2 minus and C. Minus is the operator. Argument 1 is C. Then star. B is first argument. Second argument is T3. But T3 is already stored in index 2 minus of C. So 2 is written. Index number 2 is written. So plus, for the plus, 1 and 3 are the operands. 1 is nothing but B star minus C. 3 is nothing but B star minus C. So 1 and 3. And finally, last line, you understood now, is equal to assignment. First argument is A. First argument is A and second argument is 4. 4 means partial result. Then last one, not so much important, that is indirect triples. We are using pointers to the triples. Triple representation as usual we have. Then this is just pointer, which is the snapshot of the memory. 35, 36, that's any value, memory location value. And this is the order of instruction execution 0, 1, 2, 3, 4, 5, etc. 0 means index. Index is 0. So minus of C first executes. Then 1. 1 means B into minus C second. Okay, next to index 2 means minus of C. Index 3 means B into minus C. Index 4 addition. Index 5 assignment. Just by reordering this one, you can change the expression also. Just shuffling the indexes, we can rearrange the instruction. That is the advantage of indirect triple. Next, for this question, these two are there, no? Syntax tree and DAG. For A is equal to B into minus C plus B into minus C. So syntax tree and DAG, which is showed in the next slide. See how to start minus of C. Okay, minus, I wrote minus of C, and since it is syntax tree, once again minus of C. After completing this part, multiplication with B and minus. Okay, then here also the same thing, B into minus of C. Then this plus, so plus one operand is star, another operand is also star. Finally, assignment, that is syntax tree. DAG, only one occurrence of A and one occurrence of B we have, one occurrence of C. Minus of C is completed, B star minus C is over. Then for plus, this star is, two operands are star only. So I put curved line like this. Okay, then finally assignment, A is equal to this one. This is the DAG. Next, some problems let us discuss. I solved these two. Write 3 address code, syntax tree, DAG, quadruple and triple representation for A plus minus of B plus C and A plus A star. Same example. We already wrote syntax tree and DAG. Let us discuss 3 address code also over quadruple and triple representation. Listen. Okay. Expression is this one. DAG. How to write DAG? B plus C, parenthesis the expression, consider this plus, so this part B plus C, then minus of B plus C, that is over, and finally A plus minus of C. Similarly, the syntax tree, B plus C, minus of B plus C, followed by A plus minus of B plus C. Okay. Quadruple, 4 fields, op, argument 1, argument 2 and result. Then B minus, okay, first consider 3 address code. What is T1? T1 is nothing but B plus C. Okay, then T2 you have to write minus of T1. Getting no? B plus C is called as T1. So T2 is minus of T1. Then what is T3? T3 is nothing but A plus T2. So according to this 3 address code, write quadruple and triple. If you write 3 address code, it will be easy for you to write quadruple and triple representation. So consider first line T1 B plus C. So first argument is B, second argument is C, result is stored in T1. Then minus of T1, how to write? First operand is T1, result is stored in T2, our operand is minus. Last line, A is one operand, T2 is another operand, A plus T2 plus is operator and result is stored in T3. Okay, I think you understood. Quadruple and triple representation is very easy. You can easily follow. Triple representation, you have the index here. See, observe 0, 1, 2, 3 index. Op, arg1 and arg2, B plus C. Okay, so operator is plus, argument 1 is B, argument 2 is C. Second line, and its result is stored in index 0. So for the second line, T2 is equal to minus of T1. Minus is the operator. And what is argument 1? It is T1. What is T1? T1 is stored in index 0. So 0 has to be written. Then last line T3, A plus T2. A as usual, argument 1 is A only. Argument 2 is T2. But T2 is stored in index 1. So I wrote 1. Operator is plus. Similarly, second example, DAG and syntax I already explained. 3 address code is also explained. Okay, B minus C, T1 is B minus C, then T2 is A into B star minus C, then T3 is A plus T2, then what is T4? B minus C star D, then finally T5 is the addition. Okay, if that is the 3 address code, then this is the quadruple and triple representation. So result is stored in T1, first line, this one, second line, A into T1, so very easy. Argument 1 is A, argument 2 is T1, result is T2, third line, this one, fourth line, this one, and fifth line, this one. Okay. Okay, no need to explain, I think you can easily understand. Then triple representation, instead of result T1, T2, T3, you have the indexes 0, 1, 2, 3, 4. See here, index 0 is used over here, here or here as well as here. Okay, this is about construction of syntax tree, drag, tree address code, etc. Thank you students. In the next video, let us see about code generation. That is the last topic of your this module. Thank you. Happy learning.